Okay, so we're going to start with chapter 1 for this course. And as you can see on your screen, this chapter will be dealing with the concept of matter and measurement. This is basically going to be an introductory chapter into what chemistry is all about. So let's start off with the definition of what chemistry is. And this again is something you guys should know from your previous experience. Chemistry is that area in science which deals with the composition, structure, and properties of matter and the changes that occur in matter. All right, so that's what chemistry is all about. And let's define what matter is. Matter is anything that has mass and volume. In other words, matter is the stuff or the materials that everything physical are made of. Some other key terms that you need to be aware of. Atoms, again, this is something you should know from your previous introductory chemistry experience. Atoms are the smallest distinctive units of a sample of matter. And then atoms can join together to form molecules, which are larger units, which consist of two or more atoms that are held together by covalent bonds. And later on, we're going to talk about what we mean by covalent bonds. We're going to talk about bonds in general. We're going to learn about two types of bonds, ionic and covalent, and we're going to get into a discussion of that. An example of a molecule, water, exists as molecules, and each molecule has two atoms of hydrogen and one atom of oxygen. And here we have a representation. We call this a space-filling model. So the red sphere represents oxygen, and the white spheres represent hydrogen. Oxygen gas exists in nature as molecules consisting of two atoms of oxygen. So this is the representation of the oxygen molecule. So you can have a situation where a molecule consists of one type of atom, or you can have a combination of different types of atoms to form a molecule. Okay, some other key terms. Composition. So when we talk about the composition of a substance, we're talking about the different types of atoms that make up the substance and their relative proportions. All right? So just as an example, when we talk about the composition of water, it is 2 parts hydrogen in terms of atoms and 1 part oxygen. All right? It turns out that the actual composition by mass of oxygen and water would be oxygen and hydrogen is that it's 11.2% hydrogen by mass in water and 88.8% oxygen by mass. All right? So you might be wondering, why is it that oxygen has a greater proportion by mass, but there's only 1 atom of oxygen per molecule? And that's because oxygen and hydrogen don't have the same mass. Oxygen is significantly heavier compared to the hydrogen atom. All right? And later on in chapter 3, we're going to talk more about composition by mass and how it's related to the formula. Okay, some other terms. Physical property. In fact, properties. Let me say what properties are. So when we're talking about the properties of a substance, we're talking about their defining characteristics, all right? So there are 2 types of physical properties. We're talking about, firstly, physical properties, which are properties that can be displayed by matter, by a substance, without it undergoing any change in its composition or structure. And some examples of physical properties would include mass, color, volume, temperature, density, and melting point. And there are others as well, all right? I'm quite sure you can think of some more. Now, that is different from chemical properties, which are properties that are displayed by a substance when it undergoes a change in composition or structure. So an example or a couple of examples of chemical properties would be flammability, toxicity, reactivity, and acidity. So these are all examples of chemical properties. So just to give you an actual example of 2 substances, we have in this dish here, we have copper. To one side of it, half of the dish is copper, or has copper in it, and the other half has ethanol. Now, copper, as you'll notice here, is a substance which has a shiny appearance, and it is also red-brown in color, all right? So the shiny appearance and the red-brown color are 2 statements of the physical properties of copper, because we can make these observations without the copper undergoing any chemical reaction. On the other hand, over here, we have what is being shown here is that ethanol here is flammable. If you take a lighted splint or a lighted match to the ethanol, it will start burning, all right? The fact that ethanol burns or is flammable is a statement of a chemical property of ethanol. And the reason why is because there's actually a chemical reaction taking place when we make this observation. The ethanol is actually reacting with oxygen from the air to form carbon dioxide and water, all right? So these are just two examples of what we mean by physical and chemical properties. Okay, so as we said before, a chemical property is one that when is observed, the substance is undergoing a chemical change. And a physical property is a property that when observed involves no chemical change whatsoever. So there are some other related terms, two other related terms actually, physical change. And if you understand what we mean by physical properties, that means that you should be able to understand what we mean by the term physical change. Now, when a physical change is occurring, there's no change in the composition or structure of the substance, all right? So in other words, no new substances are formed. So some examples of physical changes would be evaporation, melting, cutting a piece of wood, dissolving sugar in water. These are all examples of physical changes. And then in a chemical change, also known as a chemical reaction, the matter is undergoing some change in composition or structure, all right? So burning of gasoline is one example of a chemical change. Dissolving metal in acid, spoilage of food, these are all examples of chemical change, because in each of these cases, there's a transformation of the substance undergoing a change into something new, all right? So this is showing you that, okay, so here we have a tank filled with liquid fuel. I think this would be propane. And propane is in a liquid form under pressure in the tank here. But when it is led by this hose here into this stove right here, this little stove right here, it forms a vapor, right? So basically it is evaporating. So the transformation from the liquid state to the gaseous state is called a physical change in this case, because it's not a chemical reaction. It's basically a change in the physical state of the substance. On the other hand, when the propane combines with oxygen and it's lighted, it burns. Now that is a chemical change because the reaction takes place between the propane and the oxygen to form carbon dioxide and water. So this is just demonstrating those two different types of changes that propane will undergo. All right? Okay. Next thing we're going to talk about here is how do we classify matter, right? So we know that atoms and molecules and ionic compounds, which is not mentioned here, make up all matter, right? And remember we said that matter is anything that has mass and volume. Now we can classify, or we can put matter into two categories. All the different types of materials can be put into two separate categories. We can have what are known as pure substances, and we can have what are known as mixtures. Now, in the case of the pure substances, that can be further subdivided into elements and compounds, all right? While mixtures can be subdivided into these two categories, homogeneous mixtures and heterogeneous mixtures. So we're going to talk about each of these terms and what they mean. So let's talk about firstly what we mean by a substance, a pure substance. It is basically matter that has a definite or fixed composition that does not vary from sample to sample, all right? All substances are either elements or compounds, all right? So any substance that you come into contact with would fall under any one of these two categories, all right? Now, what's the difference between an element and a compound? An element is a substance that cannot be broken down into other simpler substances by chemical means, all right? So that's the definition of an element. It's a substance that cannot be broken down into anything simpler by chemical reactions. Now, let me just say here that you can break down an element into simpler substances, but it would not involve a chemical reaction. It would involve a nuclear reaction, right? And for those of you who have to do general chemistry 2, there'll be a whole chapter that you guys would have to study, which deals with nuclear reactions, which involve changes in the nucleus, which actually results in the conversion of an element into other elements, all right? But we won't be dealing with that in this course, all right, in General Chemistry 1. That's for General Chemistry 2. So as stated here, about 100 elements are known at this time, and each element is represented by a chemical symbol, and these are just a few of the examples of the symbols that are used to represent different elements. Okay, a compound, on the other hand, is made up of two or more different elements, and they exist in fixed proportions and can be broken down into simpler substances. So we have these examples here: carbon dioxide, sodium chloride, sucrose, etc. All right, so that's the difference between an element and a compound. An element cannot be broken down into other simpler substances by chemical reactions, while a compound can be broken down into simpler substances, and that's because they are made up of two or more elements in fixed proportions. All right? Okay, so that's basically dealing with the difference between elements and compounds. Now, when it comes to mixtures, right, if you compare mixtures to substances, what you'll find is that a mixture does not have a fixed composition, right? So if you have a mixture of, let's say, ethanol and water, right, it could be a 50-50 mixture, or you could have 25% of it being ethanol and the rest is water, or you could have 25% being water and the rest is ethanol, and so on and so forth, right? So that's one big difference between a mixture and a pure substance. Now, as far as mixtures go, there are two types. You have homogeneous mixtures, which has the same composition throughout, though the composition of different homogeneous mixtures may vary, all right? So some examples are shown here: soda pop, salt water, 14-karat gold, and many plastics are homogeneous mixtures, right? And just to show that even though within a particular mixture, the composition may be the same, but for different mixtures, the compositions will vary. If you compare 10-karat gold to 14-karat gold, they have different compositions, but both are homogeneous, because if you take any one of them and examine it closely, you'll see that the composition is the same in each case, but they're different when you compare the 10-karat gold to 14-karat gold, all right? Now, heterogeneous mixtures vary in composition and or properties from one part of the mixture to another, right? And some examples are shown here: adhesive, tape, CD, pen, battery, chair, and people are examples of heterogeneous mixture. A simple example of a heterogeneous mixture would be a mixture of oil and water. If you add oil and water and you may stir it as hard as you want to, after a time, what will happen after you stop stirring is that it's going to settle out into two layers, where you're going to have the oil at the top and the water below, and there'll be a boundary between the two layers, right? So that's a relatively simple example of what we call a heterogeneous mixture, because basically the mixture is not uniform throughout. It separates into the different components. Okay, so that's basically the difference between a homogeneous mixture and a heterogeneous mixture. All right, we're going to stop this video here, and then the next video that I'm going to post will be dealing with a very important topic: the scientific method. All right, until next time.